Good afternoon and welcome to today's web seminar, Shining the Light on Solar Panel Recycling, a Status Update. The seminar is sponsored by the EPA Sustainable Materials Management Web Academy. My name is George Burgos and I'll be managing the technical aspects of today's webinar. While we wait for the others to log on, I would like to cover a few housekeeping items. By now, you should have the GoToWebinar application running and should see the welcome presentation on your screen. If you're having technical difficulties using GoToWebinar, you can visit www.gotowebinar.com and click on the FAQs in the blue navigation bar on the left side of the page. Note, a copy of the slides are also in your handout box. We encourage you to ask questions. Please use the GoToWebinar control panel and type your questions in the area that says questions. Click send to submit it to the moderator. Please type your questions throughout the presentation. After today's seminar, there will be a short evaluation. Please take a moment to fill it out. Your feedback is vital to helping us provide the highest quality speakers and information to meet your needs. Today's seminar will be moderated by Chris Newman from EPA Region 5 Chicago office. And now I will turn it over to Chris.
Thank you, George, and thank you to everyone for joining the August 22nd, 2019 edition of the Sustainable Materials Management Web Academy, Shining the Light on Solar Panel Recycling, a Status Update. We are happy to have you participating. This 90-minute webinar is hosted by the U.S. Environmental Protection Agency to provide training and a networking opportunity to state and local governments, non-governmental organizations, and other stakeholders interested in sustainable materials management. Renewable energy is a very active industry today, and solar energy is one hotspot in the marketplace. On today's webinar, we're going to be focusing specifically on photovoltaic solar panels, like you often see on rooftops, capturing the sun's energy and converting it to electricity, from the small scale that would help to power a home to the large scale that contributes a meaningful amount of energy to the electric grid. There have been over 62 gigawatts of solar generation capacity installed in the U.S. through 2018.
With the top, so that I can see the questions.
It's really not prepared for this.
Oh, well, I don't know how to do these things, and Frank.
Can you mute? I'm hearing.
George, I just muted.
Okay.
Okay, there have been 62 gigawatts DC of solar generation capacity installed in the U.S. through 2018. With the top 10 corporate solar users adding 43% more energy production capacity in 2017 than they had in 2015, according to the Solar Energy Industries Association. So solar energy production is clearly growing. As the amount of solar capacity increases, and the first generation of solar panels are starting to near the end of their expected lives of 20 to 30 years, it's an opportunity to look at and talk about how the current next generation of panels could be managed by reusing or recycling them at the end of their life. Several staff people in EPA's Sustainable Materials Management Program have been following developments in the area of solar panel end-of-life management and kept hearing similar questions come up, such as what's in a solar panel and how do they work? How are they recycled? How big is this industry? And what's being done to productively manage panels at the end of life? This led us to today's session and presentations from these experienced speakers. Garvin Heath is a senior scientist with the Department of Energy's Natural Renewable Energy Laboratory in Golden, Colorado, and will be educating us about what solar panels are made from and some future projections. Then we will hear from Evelyn Butler, Senior Director of Codes and Standards for the Solar Energy Industries Association in Washington, D.C., about the association's work on end-of-life solar panels issues and industry data. After that, Casey Hines, the Recycling Director of Dynamic Lifecycle Innovations of Onalaska, Wisconsin, will be telling us how solar panels are recycled. And last but not least, Jennifer Martin, an Environmental Program Development Specialist from the University of Illinois' Sustainable Technology Center in Champaign, Illinois, will be reviewing information about what different states across the U.S. are doing to address the management of end-of-life solar panels. One or two burning questions after each presentation, and we will have a longer question and answer session at the conclusion of all three presentations. Please feel free to type questions throughout the webinar. Moving into today's webinar, please note the disclaimer. And now on to our speakers.
To get it bigger, hit that little pop-out button.
I have the pleasure to introduce our first speaker, Garvin Heath from the National Renewable Energy Laboratory in Golden, Colorado. Garvin, the screen is yours.
Wonderful, great. Thank you so much, and good morning or good afternoon to you all, wherever you are. Can you see my screen? Just to double check.
Yes, we.
Okay, great. So I wanted to sort of start us off and set the stage. This is a topic that I've been working on for 6-7 years or so. In particular, in an international context, I lead an International Energy Agency task, which is a group of experts from many different countries around the world on PV sustainability, where end-of-life management has been a particular topic of focus. And learning from the lessons from some regions in the world that have taken steps in advance, both in policy and technology and innovation ahead of the US, but now bringing the lessons into the US and working some here. So I thought I would start by building on what Chris had already quoted, which was the growth of solar power, in particular photovoltaics. And it's really been a tremendous growth story. This is from NREL's latest quarterly update. We provide these updates every quarter about the industry, the solar industry as a whole, and with a particular focus on PV. And you can see that in 2019, there's an expectation of between 12 and 14 additional gigawatts being added, which is a significant increase over 2017 to 2018 period. Most of that growth is expected in the utility scale, these sort of large scale installations that go directly into the transmission lines and the grid, but there's also continued growth in residential sector. And we expect that about almost 60 gigawatts of PV will be installed between 2019 and 2020, which is really close to the same amount of installed cumulatively by the end of 2018. So that's quite an acceleration. As a percent of total power generation in the US, this is a look at individual states. And as probably many of you would expect, California is by far the greatest fraction. And this is, of course, a fraction in absolute numbers. It's even greater. It's almost 50% of installations are in the state of California. But at California, it's up to, or expected up to about 19% in 2018 of total generation. That's a 165% increase from 2014, which was only at 7.2%. So really an explosion. In 2018, the US as a whole produced approximately 2.3% of its total electricity generation using solar technologies. And that's about a 3x growth from 2014. So from almost negligible before 2010 to now where it's a significant contribution in individual states at individual times. Solar is really providing a lot of the power that we all are using when we connect to the grid. But solar panels, they typically are warranted for 25 to 30 years. And so installations that are 2 decades ago are nearing their end of life. And at their end of life, they become a challenge that we have to deal with for the waste management industry in terms of making the best use of these products that are quite complex, but have value in them inherently. And so this is a projection that I was part of leading for that looked at the whole globe, but also in particular for in some individual countries. The graph is focused on the US, the map is global, and you can see by 2050 that the United States is expected to have the second largest total end-of-life PV modules cumulatively by that year. China being double that, but nevertheless, the US having a significant fraction of the global amount of end-of-life PV. And you can see the growth curves in the graph. So that annually we're really picking up by 2030 and extending to 2050. And because it takes a long time to develop both technology and policy and just the logistics solutions to dealing with end of life of any product, this is something that we need to start to address today. So just to give you some context, end-of-life PV is an electronics product, and so it kind of fits into the category of electronics waste or e-waste. In 2014, the latest data that we had available, there was a record that was set for global e-waste, and annual PV waste at that time was about 1,000 times less. But by 2050, PV panel end-of-life could exceed 10% of that record global e-waste. And that's a significant fraction. It's the highest accelerating fraction of any. And so that's significant in many world regions. And we don't want to repeat the mistakes of e-waste, where there was a great reputational hit that was taken to the electronics industry. We don't want that to happen to PV. We want to get ahead of that. So what can we do with end-of-life PV? Of course, there are, the basic, as drilled in elementary school, the 3 R's of waste management: reduce, reuse, recycle, in that order. PV research and development has set priority topics for material use reduction or substitution for different components commonly used in today's PV panels. For instance, silicon and silver are ones that have been targeted for reduction and have been reducing over the last decades. Reusing modules, potentially preceded by repairing, is conceivable, but it's practically and economically challenging. I think we have to work on the business models and the processes and logistics for this to keep costs down, to make them as valuable as possible for secondary markets, and to really develop robust secondary markets. Recycling has been a place that's been a lot of focus for PV modules, while we don't yet have robust secondary markets. And so that's going to be the focus of this webinar here and the rest of my talk. Recycling processes for both thin film and crystalline silicon, the 2 major classes of PV panels, have been developed and to some extent implemented on an industrial scale, but mostly that's outside the US, and really more development is needed here. There's significant recovery potential for different material streams that can be realized through what we call high value recycling, which is not yet common today, but is what both R&D and industry is working on. To give a bit of a background on what is a PV module and how is it composed, what are its constituents, we're focusing here on crystalline silicon modules. They represent about 90% of the market share of PV modules, so it's, I think, appropriate to focus on these. You can see the different layers that go into what's sort of the sandwich of a PV module. This is something similar to a television, a flat screen television panel that you have in your home. It's actually made of many different layers that are tightly engineered to work together and produce the product that with the reliability and performance that we expect. For PV modules, the bulk materials are glass, which is 75% or more of the weight of a module, the aluminum frame, which is another significant fraction, and then copper wiring and a plastic junction box that appears in the back. The minor constituents that have significant value include silver, as well as some internal copper components, but they're sandwiched in amongst everything else, which makes them hard to separate and extract, especially at high purity. There are minor constituents with some hazard. Lead is used for the bus bar and tabbing, as you can see labeled above. Not in all modules. Some manufacturers have gone away from using lead, but most still use it, and certainly the installed base has it mostly in there. There's also encapsulants, as you can see labeled above, that contain fluorine that could present some hazard if there were to be a thermal treatment process where it could release that fluorine into the atmosphere, where it could be caustic to human inhalation. Other materials, silicon, there's certainly for crystalline silicon modules, there's certainly a fair bit of silicon in there. How much value that silicon has really depends on how you can extract it. There are also various plastic adhesives, laminates, and encapsulants that need to be dealt with. And just to comment also about material supply for important materials in terms of them being critical, being of high value, low supply, and global trade constraints. Not in every module, but aluminum is actually listed by the U.S. government, the U.S. Geological Survey, as a critical material. There's also tin, tellurium, which are even in some silicon modules, although more commonly known to be used in thin film modules, cadmium telluride modules. Antimony is used in some glass, and gallium and indium, which is really used just in thin film modules. So why should we recycle modules? It's because we can recover valuable or toxic materials. So this is published in 2016, a report that I led where you saw the global projection of end-of-life PV modules. What can we recover from them? And this is a technical potential. We're not going to necessarily achieve this because there's going to be some losses along the way at the different stages. But you can see the glass is by far the greatest fraction. Then there's the plastics or polymers, the aluminum, which comes from the frame, silicon, copper, and other metals, on down. So silver, which has the highest material value, is a very, very, very small material fraction in a PV module. And it's distributed in a way within this tightly held, very reliable and robust to environmental conditions sandwich of the PV module so that it's hard to release. Silver also is a target for reduction in use because it costs so much. So it's a very high fraction of the silicon, the crystalline silicon module manufacturing cost. And so they're trying to reduce it. And as you can see from this chart, they've been successful, the industry, in reducing silver. So, so this then challenges the economics of recycling modules because you have going forward in the future, lower and lower silver content. But there's still, nevertheless, significant value contained in PV modules. And if we were in a technical potential sense to be able to recover all of that, these are two sort of figures in 2030 and 2050. We'll focus on the 2050 here, where the cumulative PV panel waste we estimate up to, again, cumulatively and globally, up to about 80 million metric tons. But the value, if you assign a value to all the different materials, and you assume in this technical potential sense that you can recover all of that and attain that value, it's cumulatively going to be $15 billion alone in just those raw materials, and $2 billion for the US, if you take that fraction of the amount of waste in the US versus globally. So that means new industries and new employment opportunities. There's also an opportunity for circular economy, for reintroducing those raw materials back into the production line for PV modules, where you could produce from those raw materials recovered 2 billion new panels, or 630 gigawatts, which would be a fair fraction of the total supply that's being installed in the future. Again, this is a technical potential. We're not necessarily expecting that we will be able to realize this fully, but this represents the market opportunity. We've done some evaluation at NREL and with my international colleagues of both patents as well as research done by universities and others that have been published, and in addition, government R&D plans. And here's a sort of a snapshot of some salient features of that. In terms of patents and where they've been filed, by far the largest fraction has been filed in Asia, and the lion's share of that in China. You can see the US is only 4% of patents filed to 2016. In terms of the recovered materials that are focused on in those patents, again, you can see the count is the highest for the Asian countries, but you can also see that the focus is on really the bulk materials, aluminum, glass, the solar cell silicon. So that's been really the focus so far. In terms of the research publications, most again have been focused on the bulk materials, glass, silicon, aluminum, steel, copper, and these are in the balance of system components, not even the modules themselves. And as far as the specific material, the focus has really been on silver and copper, of course, the ones with the highest material value per unit mass, but relatively low mass. And so what some of the takeaways we have from this are that the US is far behind other countries, especially in public sector support for research. Most effort to date has been focused on the easiest material targets and not integrated to recover all in one process, one integrated process, toxic and valuable materials, something we call high value recycling. There's really no one process for crystalline silicon module recycling that's emerged as preferred, and high value recycling for crystalline silicon has yet to be established in the US. And a recycling R&D roadmap, an agenda for future R&D, could help us to focus efforts towards economical and effective high value recycling technologies, especially for crystalline silicon PV. I was also asked to provide some commentary about the environmental benefits of recycling PV modules. We did this in this with this international group that I lead in a life cycle assessment for the current PV module recycling technologies and approaches. So for crystalline silicon PV modules, this same group did a survey of European recyclers. This was published in 2018, but represented information from 2016 and 17. So they're treated in recycling plants that are designed and existing for glass, metals, or electronics waste. And because the recyclers are focusing on other commodity materials, they're only taking PV and sort of to run through in a batch when they have enough accumulated. They're focusing just on the recovery of the materials that they're specialized for. So the bulk materials of glass, aluminum, and copper are really recycled. The solar cells, the silicon cells, and other materials are typically incinerated. For cadmium telluride, a thin film PV module, they're recycled in dedicated facilities, and that's because primarily the largest manufacturer of cadmium telluride modules offers recycling for all of its product. So they collect their own product, and then they recycle them in dedicated facilities. The semiconductor material, which is the cadmium and telluride, is recovered in addition to glass and copper. This is closer to a high-value PV recycling process. So we collected in a survey, as I said, for crystalline silicon modules of European recyclers that are actually recycling at the time PV. And then we also collected information that's been published by First Solar, which is the main module manufacturer for cadmium telluride. And if we look at just the recycling, so we're not offering any credits for the displacement of having to use primary metals in the next generation of use. If we're looking just at recycling, these recycling technologies are between 1% and 5% of the total environmental impacts of residential rooftop PV systems. And just for context, if you compare PV against coal or natural gas in terms of, just one metric, but life cycle greenhouse gas emissions, the benchmark value for PV systems is around 20 grams CO2 equivalent per kilowatt hour, whereas coal is 1,000 and natural gas is 500. So, you know, the recycling is a very small fraction of what's something compared to other electric generation technologies that's very, very much cleaner. The contribution of PV recycling is the highest in the impact categories because we look at not just greenhouse gas emissions, but others in terms are from the transport electricity supply into the recycling technology and use, and then the waste disposal aspects of this. The net environmental impacts, if you're considering the credits or the avoided burdens, really come from the recovery of glass, metals, and semiconductors from PV modules because they cause lower environmental impacts in their secondary recovery than it takes to primarily extract from the earth, refine them, and supply them those materials as primary resources. And it's from across these different impact categories that we evaluated, from 28% better to 750 times better or lower environmental impacts across these categories considered. So significant environmental benefits. And that hopefully is a useful introduction. I wanted to thank my colleagues in this International Energy Agency PV Power Systems Task 12, the group that I lead. Task 12 is focused on sustainability of PV, and my NREL colleagues for this work.
Okay, great. Thank you for the very informative presentation. A lot of good detail and information there for someone new to the area of solar energy and end-of-life management. We had two questions. One is, do the panels contain PFOA and PFOS? You had mentioned fluorine is an issue in waste management.
They can. DuPont is the manufacturer of the most commonly used backsheet, and that's where this comes from. But it is not the only type of backsheet that's used in the industry as a whole.
Okay. And one other question. You mentioned the crystalline silicone and the thin film. What's the main difference between those two technologies?
The semiconductor layer, which converts the sunlight to the electricity. It's also in the module construction, but that's primarily the difference. They're used both in the marketplace for the same applications and sometimes with different applications because there's a range of different applications for PV modules. But crystalline silicon, as I stated, has by far the largest market share.
Okay, great. Thank you. Great presentation. I'm now going to turn the presentation over to Evelyn Butler from the Solar Energy Industries Association. Evelyn, you have control of the webinar and we see your screen. Go ahead.
All right, fantastic. Thank you again for inviting me to come speak on the topic of PV end-of-life management. I'm happy to give you some information about, from an industry perspective, what we have been doing in terms of on-the-ground actions with our members and sharing that information with the rest of industry. So where I'd like to start is just a quick overview about SEIA's PV recycling initiative. We do have a member-based working group that consists of about 75 members of industry that meets weekly, actually. And those members consist of manufacturers, installers, developers, service providers such as finance and legal, and other groups within the solar industry. And primarily we work on two main areas. One is the continued refinement and expansion of our PV recycling program, as well as working with other stakeholders on policy or proposed policy and other ways to help encourage reuse and recycling in many of the different areas and states of the U.S. We also work quite extensively with folks like Garvin as well and his groups in order to collaborate and try to align some of our activities with some of what they're projecting to do. And so we think that is really important in terms of having the information of what's going on in other parts of the value chain of solar, and then how do we help enable our program to provide a basic footprint of how to reuse and recycle modules at end of life, but also throughout the manufacturing process as well, looking at manufacturing scrap as well as unsold modules from year to year to ensure that those are also finding a home of use and value to produce solar, but also making sure that there's a channel for those as well. And then, lastly, as I said, one of our primary activities is looking at building a footprint of reuse and recycling throughout the U.S., and I'll cover a little bit more about that in one of the slides. So to go a little bit more into specifics, where is the waste coming from? Garvin covered, some of the projections of waste from an international perspective and looking at it by some of the specific regions or countries. And what we've been looking at as well is where is U.S. manufacturing located. This is also some info from NREL, but we also look at it in terms of where is solar deployed and installed today. And the majority of what we're seeing in terms of waste that needs to be processed or managed today is coming from either manufacturing scrap. It could be coming from warranty-related incidents, for instance, damage or broken modules during logistics or handling. It could be some production or quality issues after installation that come up and are noticed during the operations process. We're also seeing some waste coming from some extreme weather events in some of the different regions, where other damage, may be due to some other climate anomalies like softball-sized hail in Texas or something like that. And then lastly, we're also seeing waste coming from technology upgrades. You know, some solar that was installed within the last 10 years or so is actually seeing an opportunity to be repowered or to be replaced with newer technology. Those economics make sense. And so if there's an opportunity to reuse or resell those modules into the secondary market, or if they need to go for recycling, we also help our members and others find resources to do that as well. But in general, the majority of waste that's actually being processed as recycling today is coming from one of these types of situations versus a true end of life, where it's actually at the point of necessity for the module to be disposed of in some way. In terms of what products are recycled today, in addition to the modules that Garvin mentioned, we also see some inverters, which have a shorter durable life than modules today. Those are being recycled and can be recycled primarily as e-waste and as other electrical equipment, and then also mounting and racking systems, including rooftop racking or ground mount trackers or posts, for instance. All of that equipment can also be recycled, similar to scrap metal or commercial or construction waste. And so there's also a channel for that as well to be disposed of. Similar to what Garvin was mentioning earlier, this is also some data from NWEL, and I won't go over specifically what he said, but what I do want to mention is knowledge of this information also helps us drive and develop where and what kinds of recyclers we look to add into our module recycling network. Currently, the recyclers that are part of our network do specialize in other types of material recycling. That's very much a necessity in terms of having a solution today, but we also work with and collaborate with other recyclers who are looking to develop PV module specific processes. And again, some of their focus is actually more intended to be in some of the other materials like silver or the semiconductors, if it's possible for them to actually recover the cell as a whole in order for it to be reused, because there's possibility that those cells are still intact and working fine. It's just the encapsulating materials or the other laminate materials that need to be rejuvenated in order for that module to be recreated and reused. So this does drive from our network development perspective, how we look at specific recyclers and their specialties and what they can do today. And then building towards the future, how we can look at collaborating with and adding additional recyclers to our network that focus on some of those more specific materials. And the other thing that I want to mention is that for us, this is a very holistic perspective in terms of the value chain. We do have to look not only just at the specific recyclers and treatment processors, but we also are looking at the other points of how solar is deployed and installed from an industry perspective, and how we share information about the resources that are available to them, but also how do we collaborate with folks at different points in the value chain, so that if there is an opportunity for responsible waste management or end of life management, that we're also looking at their needs and what considerations we might have in terms of just, for instance, just collecting modules or just transporting modules for recycling, or if for reuse, there's an opportunity to create a network of partners or suppliers that are more suited to a particular geographic area, for instance. And that is definitely another activity for our working group and for myself. And we think that it's definitely not just an end of the line activity, but something that needs to be addressed throughout that value chain. So in terms of specifics on SIA's PV recycling program, while it is a member-based program, we have developed relationships with recycling partners and reuse partners. These services can be used by anyone in industry. You don't have to be a member of SIA to actually access the services of these recyclers. We do publish their names, and all of them have websites and contact information. I'm sure they would be happy to help work with anyone who's interested in recycling. But in terms of our membership, we do develop some very specific member benefits in order to help encourage the activity of recycling and reuse. What we do from a member-based program perspective is we do a lot of the upfront evaluation of the service capabilities of these recyclers. We do like to look at their processes in terms of their accreditations, as well as how they're processing the equipment, what the considerations are for security if it's necessary, and then looking to ensure that they're maximizing their opportunities to recover as much of the material as possible. And then we also look at their downstream capabilities and resources. One very specific position that we have is that we do not want to see this waste exported outside of the US. We want it to actually be processed and, if possible, remineralized or reused within the US. But in any case, we don't want to see the waste itself exported out to be processed. And that's very important to us just from a activity perspective. The other thing that we do as well is to evaluate and help develop the recyclers. We may work with some recyclers for a few months, or it could even be much longer than that, to help them understand the technology itself. We have quite a few module manufacturing companies as members, that if there are questions about technology or information, that they have access to those technical and design experts. And then we also do an on-site visit. We also will help provide samples to recyclers to see if they need to do a practice run through their current system and to make any adjustments. We do help them with that as well. And then we also do collect data on what our partner recyclers are processing on an annual basis. And then if we're able to also get an idea of what is being recovered, sometimes that's modeled as some waste streams are combined, but that does also give us insight into how we're doing from a recycling perspective. This slide shows the current recyclers that we have in our network today, as well as their names. You'll see they're geographically all over the place in terms of location, with a lot of specialties, in the Ohio, Tennessee, that area where, for instance, glass recycling is very prevalent. We are always looking at adding partners to our network, and so I definitely encourage recyclers to contact me if they're interested in going through the process. We're very much interested in especially developing recyclers in California, Nevada, Washington, Oregon, the West Coast, as Garvin will cover later. Some of those policies are developing into more implementable schemes today. So again, cover more of that later. And then certainly what we look at is, given where solar is going to be more deployed and installed today, we would also like to look at how we develop the right recycling resources to address those end-of-life issues as well. All right, so in terms of kind of our to-do list from an industry perspective and how we look at further working on developing out the resources for reuse and recycling, we do look at it in terms of some different stages of need and necessity. And I won't go over all of these specifically, but hopefully it gives you insight into some of our thinking in terms of where we need to focus our efforts and resources to ensure that we have a fairly robust end-of-life management program. And so you'll see working definitely with manufacturers, helping develop more of the reuse or resale market. We do have some partners that we're working with today that actually specialize in this, that we're hoping to develop their opportunities even further, as well as develop the network and the channel at which buyers and sellers are actually connected to make more activity in this area. And then, of course, remanufacturing and refurbishment is another area that we would like there to see more activity, but there are some regulatory challenges there that we're looking forward to working on and addressing, and then obviously continuing to work on improving the resources available for recycling as well. And then also working on communication with industry, with stakeholders, with consumers so they understand that there's actually resources available to them. All right, so that was my last slide. I'm happy to take a couple of questions.
Okay, great. Thank you, Evelyn. We had a few questions come in, so I'm just going to select one or two, maybe three. One question is there a link to the recyclers posted on your website? You had that slide with all the recyclers. Is there more information or a link out to their websites or other information on the association webpage? Yes,
actually there is a list of recyclers on one of our web pages. It also, I believe, has their specific websites included there. I will have to check back in the slides itself. I'm not sure if it's in the PDF handout, but if you go to the SIA.org website and you do a quick search on recycling partners, it'll take you to our list of recyclers there.
Okay, great, thank you. Another question came in about collection data, if SEIA would be sharing collection data for panels that are recycling things.
We do aggregate and anonymize that data from each of our partners. We've had, typically what we will do is either at our annual conference, share that data that we have collected. We're not quite finished with that exercise right now. So I'm not sure if next month at our SPI show we'll be able to share that, but we will publish an aggregate of that data probably in the fourth quarter.
Okay, great, thank you. We have one more question, and with this I'm going to turn it over to, I believe, Tracy Atagi in EPA's headquarters office. We'd had a few questions about the waste characterization of the solar panels, and if those solar panels would be characterized as hazardous waste that are going for, I guess, would be disposal. So if they could open up the line, I'll open up Karen Pollard's line. I believe Tracy's with Karen. And Karen and Tracy, do you hear us?
Yes, we do.
Okay, great. If you could go ahead with a response to that question.
Sure. Well, determining whether or not the panels would be hazardous waste would depend on the amount of hazardous constituents in it. So it would depend a lot on the manufacturing, the type of solar panel. If they're above the TC levels and are being disposed of, then yes, they'd be hazardous waste. The toxicity characteristic levels.
Okay, great. We may have some time later on for some more discussion, but right now we need on to our next speaker, who is Casey Hines, who is with Dynamic Lifecycle Innovations in Onalaska, Wisconsin. So Casey, thank you for joining us today. Evelyn, thank you for your presentation. Casey, will you see your screen? So the stage is yours. Go ahead.
All right, thanks a lot, Chris. Yeah, so I am Casey Hines, the sales executive for our recycling division here at Dynamic Lifecycle Innovations. I don't have our website here on my main page, but our website is thinkdynamic.com if anybody's interested in just checking that out to see a little bit more about what exactly we do. So a little bit of background about who Dynamic is and why we're involved in today's webinar. We are an electronics recycling company that was formed back in 2007 in La Crosse, Wisconsin, originally under the name Dynamic Recycling. Just last fall, so just about a year ago, we did change names to Dynamic Lifecycle Innovations. Speaks a little bit more about what exactly we do and diversifies a little bit more of what we're doing here. So as it shows here, we are headquartered in Onalaska, Wisconsin, with about 380,000 square feet. That consists of two main buildings here, one being about 250,000 square feet that houses our ITAD operation, as well as most of our manual disassembly. Just across the street, we do have an additional 130,000 square feet, which houses our main processing equipment, as well as a brokering operation. And then, as you can see up in the top right corner there, our team has grown significantly since this picture was taken. About 2 years ago, in celebration of our 10-year anniversary, we now employ about 250 people here between Wisconsin and Tennessee. Also wanted to touch a little bit on the certifications there that we do hold. There are a lot of certifications and standards for the recycling industry. A lot of those do translate over to solar recycling as well. There are a few that do not. So as you can see, they're a NAID AAA certification or ITAR compliant. Those are a couple that are geared a little bit more towards the electronics recycling. But certainly the R2 certification and the E-Steward certification do speak directly to solar module recycling as well. There are a lot of similarities in solar modules with electronics. So certainly the R2 certification, which is the responsible recycling certification, it really promotes a safe and environmentally conscious disposition of electronics equipment and electronic materials. Similarly, the E-Steward certification is an e-waste certification that really focuses on proper disposal and export of hazardous electronic equipment and materials. So those are a couple of the certifications that when you are looking for different recyclers or different groups to work with, those are certainly some things that you can look to see if your partners are holding those or if they're at least meeting some of those same expectations. Additionally, the ISO and OSAS certifications really focus on the environmental management systems, quality management systems. So really making sure that we're handling the material the right way, materials not just getting dumped, and really keeping the environment first and foremost in mind there. Additionally, the OSAS certification is really occupational health and safety, making sure everybody's going home safe at the end of the day and people aren't getting hurt. With that, also just wanted to sort of touch on some of the different insurance coverages and things like that out there. Dynamic does carry a $10 million pollution liability insurance. Really, this offers reassurances to customers, so that they know that they're covered when material is shipped here. Really protects our customers in case anything does ever go wrong with the material that was sent our way. So yeah, where are solar panels coming from? Some of this was touched on a little bit earlier by Evelyn, but actually there will be a little bit of overlap in different areas. But certainly, there's a few different areas that we see these really generating from. One being manufacturers, so modules that are damaged either during the manufacturing process or the distribution process. That can be anything from a pallet dropping off a forklift as it's getting moved, or a semi getting rear-ended out on the road while it's out making a delivery. Those modules, the manufacturers they hold high standards of themselves and really the products that they're putting out, and they don't want to be putting out products that may get out and be damaged as soon as it's being installed. So really, they're going to look to get that material recycled before it ever causes any issues down the road. Also, waste management organizations or companies, they're really dealing with a lot of the modules that are brought in from residential or corporate generators. There is a limited number of recyclers here in the States that are taking modules at this time. So I think there's certainly a need for these organizations to be able to accept the modules in areas where people are struggling to find a proper outlet. So a lot of times, they're also going to be working with, your do-it-yourselfers, people that have the outdated or broken equipment and don't, maybe not be under warranty, or they may not have worked through a company or an installer that's going to put it in for them. So really, they need a way to properly dispose of that. Also, obviously, the solar installers themselves, they're the ones that are putting in the new modules, decommissioning the old ones. So a lot of times they're going to have their hands on the old modules that are either broken or no longer producing the same amount of electricity that they once were, not running optimally anymore. So, they're obviously going to have their hands on a lot of those and need to have some end-of-life outlets as well. So, really, the reason that these groups are seeing the modules are, just about anything that you could imagine for why a module would be entering the end-of-life stream. So, they're no longer as efficient as they once were, or simply the solar array is getting upgraded. If there's weather-related damage, lightning strikes, hail damage, windstorms, anything like that could cause damage to your solar panels, obviously you got to get rid of them, and people want to do it in a safe way. Also, if there's any problems with the module themselves, hot spots, delamination, anything like that, where again it's not running at peak performance anymore and needs to get replaced. So the resource recovery process, so there's a lot of great technologies out there and processes out there, both domestically and internationally. Not everybody is doing it the exact same way, certainly as Garvin sort of touched on earlier as well. So definitely do some research about what recycler you're looking at and what they're doing with the material and what makes the most sense for your organization. There's definitely delamination technologies out there. There's chemical bath technologies out there. Certainly the one I'm going to touch on a little bit is again, what we know best being in the electronics recycling industry, which is running through a shredding operation or processing operation. I do want to point out that we do only accept the crystalline silicon modules. As Garvin mentioned earlier, there is a manufacturer that is accepting all of the modules that they manufacture themselves in the thin film realm. So we certainly just stick to the crystalline silicon at this time. There are a lot of similarities in solar modules and electronics, which allow for these technologies, shown here to really cross paths. So, first and foremost, the modules can be run through a shredder. Sometimes they do need to get cut down to size a little bit, but they can run through a shredder, which is going to start that liberation process of starting to liberate some of the glass, liberate some of the steel, plastics, things of that nature. Metal sorters, great at doing the same thing. They're going to be able to isolate some of that glass and some of that plastic that has been liberated that doesn't necessarily have that adhesive to it. Same with optical sorters. It's going to kick out some of those the copper and the precious metals, your aluminum as well. So there are a lot of different technologies within these processing facilities that allow for liberation of the solar panels and cleaning of that material and really stripping down to those bare commodities. So yeah, I think both of these were sort of already touched on as well, but just wanted to add a few things as well, regarding the contents of the solar panel and some of that relative material value. At its simplest, the module consists of the metal frame, which roughly makes up about 8%, the aluminum frame, which roughly makes up about 8%. The glass is anywhere from 75 to 76, again, depending on who the manufacturer is. The silicon cells themselves typically make up around 5%. Your backsheet, your plastics make up around 10%. Your metals, such as copper, make up around 1%, and then that silver, lead, tin make up less than 0.1%. So, in looking at the relative material value, your silver makes up about 47%, which again makes up technically less than 0.1% of the module itself. You combine that with your aluminum, which is just under 75% now with those two, the material value. They only make up less than 10, or right around 10% of the module's content. So, and I'll touch on this in a slide or two, but there are some declining markets, or there's shifts in markets that a recycler always needs to pay attention to and keep an eye on. But sort of that, we are seeing a shift in some of the aluminum markets. So, the declining aluminum markets, along with the possibility of less silver going into some of this production, certainly has the possibility to lower some of the intrinsic value of the panels themselves once it comes to the recycling side of the house. So refurbishing and reuse, is certainly something that a lot of recycling companies are paying attention to. As I touched on earlier, there's different certifications that are out there that really push for that refurbishment and reuse above all else. So just doing a couple of tips for ways that a producer of the solar modules could be paying attention to see if it's going to qualify for that secondary market. Really, the first being to do some visual inspection for integrity yourself. Make sure there's no sunspots or cracks, shattered glass, issues with the back sheeting. Those are really issues that people currently, companies aren't going through and physically refurbishing or fixing up just due to the complexity of the solar modules themselves. Those aren't easy fixes. Certainly, if there's a chip or two in the glass, that's not a big issue. If there's minimal denting to the frames, again, that's not going to be a make or break for the ability of the module to be reused. But some of those other issues really do eliminate it from that secondary market possibility. The other big thing is really identifying qualified modules on the front end. It's going to allow your recycler to offer greater value back for that material. If all the modules are showing up, all mixed together, and your recycler is having to go through, put in time and labor to sort out the shattered glass from the modules that essentially are in good condition, there's going to be time and labor involved in that, which again is going to sort of eat into some of those returns that they're able to pass along back to the generator of the material. So looking at, I guess, some of the markets, there are a lot of different options. One that I would definitely suggest doing your research on, looking into, are the charitable projects that are available, both domestically and again internationally. There's a lot of groups here in the States that do a lot of great work overseas, third world countries, providing power to hospitals, schools, things of that nature. So if you're looking to donate modules that still have secondary value, secondary life to them, certainly do some research and look for some organizations that you'd like to get involved in. Otherwise, when we're getting modules that we're looking to resell or put back into that secondary market, there's strong markets in China and the Middle East, Africa. Again, they're not really looking for any sort of warranty on these modules. They understand that once it's done, it's done. But they're really just looking for an option to provide power to areas that don't necessarily have it or don't have it readily available. Also, peripherals can be resold, can be reused. I know, like Evelyn touched on earlier, or maybe it was Garvin, I apologize, but I know the inverters, don't have a very strong lifespan, so they do go out fairly quickly. But if you are simply going through, updating your system, refreshing your system, and the material is still working, let your recycler know that. Try to keep that separated or segregated from anything that isn't working. There are secondary markets for some of those peripherals as well, but typically if it's just all thrown together and it gets to your recycler at the end of life, really they're not going to go through and test some of that material. Most of the time it's just going to move through the recycling process and be broken down. Another question that we were asked to sort of address or touch on was, what do we hope for in the future for reuse markets? And really, we just hope to find new channels for parts and components for the material that isn't broken and is still functioning. Again, like I said earlier, the R2 certification that we hold really pushes for reuse above all else. So having more secondary markets would allow for even cheaper solar options, both domestically and internationally. I understand solar is getting cheaper as a whole in general, but certainly having even cheaper options for people is always a good thing. So one of my last slides here, I guess, is sort of to touch on the scrap market, and what issues are we facing in the recycling industry, and what do we see for the future? So really the three big issues that we run into that we're currently working through, especially on the electronics recycling side, are the plastic, aluminum, and glass. obviously, as many people know, China has put up their national sword policy, which essentially eliminated plastics from entering the country. A lot of plastic here from the States was moving to China or other southeastern countries. With China's national sword policy going in first, some of the other outlets sort of shifted to these other southeastern countries. They sort of got flooded with that shift, and they essentially moved to some of the same policies and really stopped importing from the States. So with that, domestic companies are acquiring equipment and to sort and separate different types of plastic, and there is a lot more attention being paid here in the States. So really the future forecast there is we're likely to see more material processed and recycled domestically. Obviously, we're not there right now. You're not going to be there tomorrow, but there is a lot of attention being paid, both from manufacturers, from recyclers, in the industry in general. So certainly that one is looking up, I feel like. The aluminum, as I mentioned earlier, that is an area where we have seen a decline in value, roughly 4.5% here in 2019 alone. A big reason for that is there is still an oversupply versus demand right now. There's also some uncertainty on our end, in the recycling industry in general, whether that price of aluminum has bottomed out or if it's going to continue to downtrend. So, we'll see how that goes. Again, kind of going back to some of that relative value in the modules, it makes it difficult to sort of forecast 5, 10, 20 years down the road, without knowing what some of these commodity markets are going to do and what those are going to look like. And then also glass has traditionally been a difficult commodity to manage, as it needs to be a very clean, very pure product for end users. So it does require a pure liberation of all the commodities. Again, the evolving module composition and fluctuating markets are really going to dictate, the future value of these panels. And as that shifts, your recyclers are going to have to sort of shift and adopt new ways of processing in end markets with their material. But that's just part of the game, I suppose. I guess the last thing I wanted to mention real quick, as a recycler, obviously we feel it's important to educate the public on a few different things. Obviously, one being that there are a lot of great companies working hard to offer viable recycling options. So again, just try to find out which recycler meets your needs best. Do your research, talk to your recycler, ask the question. And then also there are certain dangers associated with putting these in our landfills. So with contamination through leaching, and contaminating the water and soil and things of that nature. So we certainly see a great need for recycling to continue adapting and developing a strong market here in the U.S. So with that, Chris, I'll turn it back to you.
All right, great. Thanks, Casey. Great presentation and a lot of great information in there. We had several questions come in, and there were a few questions in kind of two categories. One is, in terms of the cost and revenue areas and I'm going to summarize those into kind of two general questions. In terms of the costs and the revenue streams from recycling solar panels, I imagine it's the same that we may see with electronics recycling, where there's revenue coming in from the sale of reusable equipment, maybe sale of parts, and then sales of the processed commodities that are going on to go be fully recycled and put into the next generation of products. So there's revenue coming in there. There are costs for the handling and the shipping and the processing, and having the facility that's capable of doing it to a condition where the material is reusable. And then there's also revenue that's coming in as a cost or a fee charged to the person who is tendering the material to you. Is that the same in solar panel recycling, or are there any differences?
Essentially, you're right. It is the same. Obviously, there's different outputs through the processing of the material. So a computer printer isn't going to necessarily produce the same output as a solar panel. So you got to look at some of the end markets or the output of what's going to come out of those. Obviously, there is relatively low volumes of precious metals, in the panels themselves. So it does take a larger volume to really produce maybe the same or an equivalent value of, same palette of, say, computers.
Okay. There were also a few questions about offshore donation and reuse. Are there specific organizations or any website links that you're aware of that may be helping to facilitate these kinds of relationships? I know, as you mentioned, there's, as Evelyn, I believe, mentioned, there's some hesitation and interest to make sure that this is all done properly, so that we don't end up with a similar situation that we ended up with electronics. But are there any other organizations that are able to help facilitate these donations so that they're going to proper end uses outside the United States and don't end up as waste or burden on other countries?
Sure. Yeah. So I guess I don't have anything handy that I could point to and say here's a list of all the organizations and things going. I've had a lot of conversations with different industry folks. I'd be happy to reach out, maybe get some names of some different organizations. Again, it's been through a lot of conversations that I've learned of different charitable organizations. So I'd be happy to do a little digging on my end, get some names of some different organizations that I've heard of and that I was very interested in, and be happy to pass those along. Okay.
And since you're more involved in the recycling end, like you've been talking about, but I was just wondering, and maybe this this is a better question for later on. I think it might hit on a few different speakers. So with that, that's our time for the burning questions with Casey. I'm ready to move on to our next speaker. We're now going to turn the presentation over to Jennifer Martin of the Illinois Sustainable Technology Center in Champaign. Jennifer, the screen is yours. Thank you.
Thank you, Chris, and thanks, Casey, Evelyn, and Garvin for your insights into the industry and how you foresee your projections in the future. I am going to touch on a state perspective on how we are beginning as states to address a plan for the end-of-life management of solar panels.
Jennifer, real quickly, could you go to up at the top of your screen, the display settings? Right now we're seeing, do swap.
All right.
There we go. Perfect. Thank you.
Can you see it now? Okay.
Yes, we see it full screen.
Great. So first, I'm just going to give a little background on who we are and why we saw an interest in working in this realm. I am with the University of Illinois Prairie Research Institute, and as an institute, we are an interdisciplinary research institute. We have 5 state scientific surveys, and within those surveys, we do research on water, energy, agriculture, public health, environment, climate adaptation, and cultural resources. Specifically, I am out of the Illinois Sustainable Technology Center, and through our center, we integrate applied research and technical assistance to assist the citizens and businesses and government agencies in the state to prevent pollution and conserve resources. We also work on waste reduction to better protect health and the environment. At ISTC, we began to really think about how this can start to impact our state as we saw the passing of the 2016 Illinois Future Energy Jobs Act. In 2017, we wanted to address this issue, which establishes a 25% energy generation from renewable energy to be within the state by 2025. We'll see additional requirements with that as this act moves along, and more than likely see additional of more than 2,000 megawatts of solar installed in the state. As of July 2019, we had approximately 120 megawatts of solar installed in the state, and that converts to a little less than 400,000 modules currently installed right now in Illinois. With this new 25% renewable energy requirement, Illinois will approximately add an additional 6 million solar modules by 2025, and that equates to approximately 120,000 metric tons of solar modules. Right now, the state lawmakers have recently introduced the Clean Energy Jobs Act. And through this act, if it passes, it will ensure an equitable benefit across the state, moving Illinois towards 100% renewable energy by 2050. This would cut carbon pollution from the state's power sector by 2030 and include electrification of transportation. As we saw in Garvin's slide earlier, we kind of took this data and based it on how this equates with our projections under the Future Energy Jobs Act. And based on this research, we're finding approximately between 62,000 and 1 million modules in Illinois will reach their end of life as early as 2030, and between 21 million and maybe even 55 million by 2050. So this is really kind of something we want to get ahead of and be prepared for once we start seeing these large projections in the future. Some state concerns, this is in general, in talking with other states and what we are seeing here in Illinois, we're worried about broken and damaged modules that are currently finding their ways to landfills. This is filling up limited landfill space, and we want to prevent that in the future from happening. Some of the solar waste could also include heavy metals, as was mentioned earlier, and at certain levels, this could be classified as hazardous waste. And then lastly, conservation is necessary for these finite resources that we heard about earlier that are mined to create modules for this industry. Some state challenges for preparing a plan to manage this waste includes ensuring proper recycling policy or interventions that do not impact a transition to renewable energy. These requirements of a program should not overburden one industry stakeholder over another. And then as we prepare, we will need to see funding mechanisms in place to handle this waste responsibly. As Casey mentioned, it's very unpredictable what the end markets will look like. So we really need to take a good look at these life cycle assessment costs and how those may change over time. Who is responsible for these life cycle costs, and how does this impact solar energy development is a question we're asking as a state. Does this happen to fall under manufacturer's responsibility or the developers, or is this a customer cost? Infrastructure and collection systems need to be set in place for an efficient use of funds once the recycling and reuse program begins. And these programs will take administration to oversee. So what are the costs involved with that? And then lastly, protection of the funds is necessary for a long-term recycling and reuse plan. So as we start to think about strategies for creating this circular economy, right now, many states see a concern for preparing this plan to manage the waste. Some examples that we've talked with in the past are Illinois, Minnesota, and North Carolina, just to address a few states that are now working in trying to figure out a plan cohesively. These strategies can include early engagement of national and local stakeholders, including SIA and NREL and installers and recyclers. Energy recycling market experts also are needed to be at the table to really understand how each state's energy mix is looking and projections into the future. State agencies as well as educational institutions, and then advocacy groups are really important to have at the table as we talk about how this impacts communities. The impacts of policy, regulation, and landfill bans are also necessary when thinking about strategies for a state, and then preparing opportunities for a diverse workforce as we see a new industry emerging from this. So I want to pass the screen back over to Garvin because he has some information on specific states that are addressing these issues currently and the types of policies that they are seeing within their states.
Thanks, Jennifer. So back over to us, NREL this year has initiated a survey of U.S. state-level policies and initiatives related to PV recycling. We're evaluating, this started out as what we thought was going to be something small, and it's turned out to be much larger. So we're evaluating across a pretty wide landscape of policies, laws that have been enacted, are currently proposed and under discussion, or some laws that have been proposed in the last few years, regulations promulgated and proposed, as well as initiatives, which are either stakeholder initiatives run by states, for instance, the one that's being run by Illinois that Jennifer leads, voluntary industry initiatives like SIA has, as well as codes and standards. The purpose is to provide this kind of landscape as increasing number of questions are being asked about PV modules and expected end of life, and what are some of the laws, what are the rules of the road, and also what's being considered to establish those rules. So today, we don't have time to review all of this. We're just going to do a quick overview of some of the laws. We have an expected publication in the fall of 2019 for this broader survey. So those that are enacted, Washington State came out first. They're the very first state that requires recycling of PV modules. In fact, what they require is extended producer responsibility on manufacturers selling solar modules into the state. I believe the implementation, or the date when this is, when plans have to be approved for, and any manufacturers that don't have plans approved would not be able to sell into the state, is 2020. So they have to create a system of collection and then reuse of recycling with a plan that's approved by the state at no cost to the system owner. North Carolina just recently has a law that's passed, requires the Environmental Managing Commission to develop regulations. So they haven't been developed yet, but the law authorizes that to oversee end-of-life PV management and utility-scale solar projects. So there's a lot of uncertainties about what the regulations are going to look like, but the law is there that starts the process to require this. In New Jersey, they've established a solar panel recycling commission, again, to develop recommendations and report recycling and end-of-life management options for the state. So no specific requirements yet, but the commission is now established. As far as other things that are in sort of some state of being proposed or in implementation, California is probably the most noteworthy one. This is a process that's been going on for many years with the California Department of Toxic Substances and Control. And it's in the process of classifying PV modules as universal waste, would be to provide a less stringent requirement and make it actually possible for end-of-life PV modules to be easier to collect, transport, and recycle within the state and across state boundaries. In New York, There's a bill that would require manufacturers selling solar modules in the state to implement a collection and recycling program at no cost to the system owners. So it echoes in broad brush the Washington state requirements. It also creates a landfill ban, which is another policy that many states are considering, sometimes as a first step towards any sort of recycling or collection system requirement. North Carolina has another bill that would prohibit utility scale owners or operators and module manufacturers from disposing solar modules and energy storage equipment in landfills, and would require module manufacturers to provide a take-back program, which includes recycling and reuse of equipment. So that's just a very brief summary of the landscape of some of the activity in states. There are other bills that have been introduced in the past in a few other states besides the ones that are listed here. And of course, there's increasing questions, and I would speculate that some additional states are going to start to have some activity in this area in their legislatures with their state departments and agencies, and certainly with stakeholders. Thank you.
Okay, thank you, Garvin. And Jennifer, do you need control back?
No, I think Garvin covered it well.
Okay, wonderful. So thank you again for your presentation. We've had a few questions come in. I'm going to take a look through and find a few and see if we can summarize these. One question is, a few questions have come in regarding the toxicity criteria or hazardous waste criteria for solar panels. I was wondering if any of our speakers have any information or know of any published information on the toxicity criteria or the hazardous waste status of any solar panels that has been done.
I could take that. This is Garvin. This is a challenging topic. I mean, under the law, it's required that whoever holds this waste has to do this test. The test is sometimes done, I believe, by manufacturers, and of course it's done sometimes by those who hold this waste, but it's not generally made public. So we have a dearth of information about how solar PV panels pass or don't pass. And there is some research, more troubling perhaps, that has been published that indicates that the TCLP test was not designed for something as large as a solar module, and how you take your samples to produce the amount of material that then goes and gets tested by a lab, and the protocol that the lab uses for doing that test, when done under different but repeated circumstances, so as in taking your samples from different parts of the PV module selectively, you can get wildly different results. You can get the same module passing or not passing that test. And sometimes lab-to-lab variability can mean a module passes or does not pass that test. So this is work that's been led by the Electric Power Research Institute, and they've sponsored research at the University of Arizona that's looked at this. And so it leaves some questions about even what should be the protocol to performing this test, let alone what the answer would be. So unfortunately, that's the state of affairs right now, in my view anyway, and I'd welcome others of our speaker set to chime in about where we are with understanding about whether they, under the US laws, solar panels would meet or not meet the TCLP hazardous waste determination.
Okay, thank you, Garvin. Do any of our other panelists have anything they'd like to share with us on this? Okay, thank you, Garvin. Question for Casey in regards to the recycling processes. Do any of the recycling technologies, what do they use to extract the particularly the silicone or the metals that are involved. Dynamic life cycle innovation seems to be using a lot of shredding. But how do they separate a lot of these materials and then separate them into a quality that is recyclable or worth recovering downstream?
Yeah. So as Garvin mentioned earlier, a lot of previous methods were just sending them straight to incineration. Currently we're doing a lot of assessing with the material to determine the optimal end markets really. So obviously the material needs to be very clean, segregated to different standards depending on the end users. But I know there's the option of having the material smelted, where you could smelt out and extract the precious metals that way. But certainly, we're looking to still doing some research into that, and like Garvin said, try to look for that high value recycling and be able to optimally capture as much as we can.
Okay, thank you, Casey. Another question for Garvin. In terms of going forward with the various materials inside of solar panels, particularly towards the solar cell, the composition seems to be pretty stable going forward in terms of gallium indium, I believe it would be. Are there alternative semiconductors being developed? As we talk about the hazardous waste classification of this material, there are some semiconductors that do use minerals that are on EPA's RCRA metals list as hazardous waste. Is there work in the industry to try to move away from those for the semiconductor portion of a solar panel? Two questions.
Solar photovoltaics is a rapidly growing but still evolving field of manufacturing. And manufacturers, both incumbent and new, are testing different module designs regularly. They're testing different backsheets. They're testing and using different solders. And as I mentioned earlier, lead is commonly used in solder, but for some manufacturers is not used anymore. For semiconductor materials, yes, there's certainly testing going on about different semiconductor materials. There's another thin film variety called SIGs that does have some market share, but that does have some metals that would be considered on EPA's RCRA list, as well as being critical materials. There's certainly a lot of innovation in the research space going on with a field of photovoltaics called perovskites. Perovskites is a class of materials that's used for very thin modules that are achieving some pretty impressive efficiencies of converting solar sunlight to electricity, but have typically relied on lead as part of their formula. And of course, that's going to be a problem going forward as far as its toxicity. But it's also useful to to know that cadmium is a heavy metal that's certainly listed in RCRA metals list. But cadmium telluride PV modules are a reasonable market share. They're prevalent in the U.S. It's a U.S. company that is the leading manufacturer of this. And from the beginning, they've paid a lot of attention. They really had to, but they paid a lot of attention towards the management of cadmium. And they have, succeeded in developing the most robust and commercial scaled and iterated high value recycling process of any. So they maintain and manage, what would be a heavy metal of concern. And they prevent by their own collection those modules from going into the landfill. So, it's in terms of design for recycling, one would certainly prefer to avoid those materials, but in some cases where performance or other attributes are enhanced, as in the case of cadmium telluride, then there are ways to control and manage those substances.
Okay. Well, great. Thank you for that insight, both on the chemistry and on what that particular producer is doing. With that, we've run out of time for questions. We are at the end of our time. So I wanted to thank all of our speakers for sharing their knowledge with us today. I think we had a great webinar session. Many people have been asking about handouts and the presentations. Those presentations are available in the handout section of GoToWebinar for download now. And finally, most of all, we thank all of you, our audience, for joining us this month on the SMM Web Academy, and hope that you'll continue to join us. If it is you that this program is designed for, so please complete our evaluation and give us feedback on how we can meet your needs. We'll post the webinar audio in about 2 weeks. We invite you to join us for the next EPA SMM webinar, Oregon's Wasted Food Strategy, Highlights on Current Work, Research, and Next Steps. This will be Monday, September 16th. Look for future emails on registration details. Again, I'd like to thank our speakers for their presentations today and taking their time to be with us. And this concludes today's session. Thank you, and have a wonderful rest of your afternoon. Thank you.